Good morning all. Good to see you all through this social platform again. Today I'm gonna take a topic on architecture of 8051 microcontroller. I'm myself Aiswarya. I'm working as an assistant professor in the Department of ECE and Emmanuel as a JJ College of Engineering. Okay, so let's begin the section. Microcontroller. Actually, what is microcontroller is? A microcontroller is an integrated chip designed under very large-scale integration. Very large-scale integration is nothing but the full form of VLSI techniques that consist of a processor with other peripheral units like memory, input-output port, timer, decoder, ADC, etc. The microcontroller has memory, input-output port, timer, decoder, along with the main technique of processor called VLSI. VLSI is nothing but very large-scale integration, which is actually a process of creating integrated chips. As we all know, we have heard commonly as ICs, isn't it? So the ICs is called as integrated circuits, which is the process. The VLSI is the process of creating the integrated circuits by combining 1,000 to million of transistors on a single chip. The transistors, not one or two, actually 1,000 to millions of transistors are combined on a single small chip. That is a compact chip. So that is called as ICs, and these ICs are produced by the process of VLSI. The main goal of the VLSI technique is to attain high performance, low power consumption and compact size. As I mentioned earlier, this IC is a small chip. It is a compact size for electronic devices. So the application of this VLSIs may be smartphones, AI accelerators, and many kinds of IoT devices. IoT devices is nothing but Internet of Things. Example, smartphones and many kind of cybersecurity cameras, etc. In future, the VLSI may be used in processing of making 3D ICs, nanoelectronics, AI-driven designs, and even in quantum integration. Okay. So microcontroller is basically designed in such a way that all the working peripherals are embedded in a single chip with the processor. Microcontroller means which has the processor in which all the working peripherals are embedded in a single chip. Only it is embedded in a single chip. So this is the basic architecture of 8051 microcontroller, where ALU is present, then registers are there, stack pointer, program counters, program counter incrementers, DPTDR, program address registers, RAM, ROM, timer and control unit, instruction registers, special purpose registers, latches, buffers, and the ports are defined as 0 to 3. That is 4 main section of ports in which the ports can be controlled. Interrupters, timers, serial controllers, everything are given here. There is nothing else. The architecture is actually a 8-bit hardware design. Okay, this architecture is actually a 8-bit hardware design integrating the CPU, memory, peripherals on a single chip. As we have learned before, all these peripherals are encoded inside a single chip. Its features is a 40-pin package. Actually, it is a 40-pin package and 128 byte RAM. The RAM may be 128 byte and the ROM may be, where is the ROM here? Here. The ROM may be 4 KB ROM. Then 4 input-output ports are given, timers, serial ports, then serial common supporters, communication supporters were also here given. Then the CPU here, which helps to execute instruction, manages data flow and controls the peripherals. The main work of the CPU here is to execute instruction, manages data flow and controls peripherals. Whereas the ROM, the main work of the ROM is actually it is a program memory. The ROM here is a program memory which is typically 4 KB. It is KB, which stores the data permanently. Again, a RAM. The RAM is a 8-bit. The RAM is a 128 byte storage which is used for storing the temporary data. Again, The input output ports given here from 0 to 3, actually 4 input output ports are there, which is divided as port 0, port 1, port 2 and port 3, 4. So again, the serial communication port enables UART based data transfers for external devices. The timers and counters, which are 16-bit timers for event counting, delays and the generation of clocks. Oscillators and clock circuits which are connected here externally for chip oscillations for giving the timing signals. Then bus system. Bus is nothing but the connecting bridge. So it includes a 8-bit data bus in which the data are flowing, a 16-bit address bus and control signals connecting CPU with the memory and the peripherals. Okay. So that was given here. CPU is a 8-bit processor. 8-bit heart, the processor is the heart of microcontroller. Okay. What is given here? See. The CPU is the CPU processor is the heart of the microcontroller. Again, memory already I explained, RAM and ROM. RAM has 4 KB. ROM has ROM, which has 4 KB ROM. It is changed and modified. It is changed and modified. And RAM is a 128-byte RAM. It is called as data memory and the stores the data temporarily. Okay. Then input and output port has 4 parallel ports. As I already told, 4 parallel ports, port 0, port 1, port 2 and port 3. Timer and control units create a time gap or delay between the years. So to create a time gap or delay in which the system can produce 2 delays simultaneously. Okay, all this I have explained previously. Again, the flag bits and PSW. PSW is nothing but the program status word. It is 8-bit register, also known as the flag register. The PSW is also called as what? Flag register. It is 8-bit wide, but 6-bit is used. It actually has 8-bit, but it only use how much? 6-bit. The two unused bits are used as defined flags. User defined flags. So there are 8-bit, but only the 6 are used. The remaining 2 unused can be used as a user defined flags. So again, the data pointer, that is DPTR, that is called as a 16-bit register. Okay. So the accumulator R0 to R7 is used there. So again, the word DPTR is meant for pointing the data. It is used to access the external memory of the address. So now the characteristics of 8051 microcontroller. An 8-bit it is a 8-bit processor, as we already know. Data memory or RAM is 128 bytes. Already we have learned. Program memory, it is also called as ROM. It is also called as 4 KB. 2 timers of 16-bit each. That is 16 into 2. Then again 8-bit of data bus, 16-bit of address bus, offers bit addressable format. Then special function registers, some SFR, special function registers are used. Then 32 input output port lines are used. That is 0 to 7. That is 0 to port 0, port 1, port 2, port 4, 3, like that. Again, real-time applications of 8051 is nothing but home appliances. It is used in home appliances. Okay, it is used in home appliances, used in washing machines, micro ovens. These are all the home appliances. Then automotive system controls dashboard indicators, fuel injection systems, and automatic braking systems in automotive electronic devices and vehicles. Robotics, power autonomous robots for movement control. For movement of the robots, this is used. Then medical devices, embedded in devices like digital thermometers. We all know digital thermometers, right? Then blood pressure monitors and infusion pumps. Again, it is used for industrial automation, manages the motor control, conveyor belts control, moving speed of the conveyor belts, etc. Again, it is used in telecommunication system, nothing but used in telephone exchanges and mobile communication modules for signal processing. Again, remote controls, operates TV remotes using IR rays. Then security system, used in cyber security. As I already mentioned, it is used in IoT devices, smart devices, right? Like that. Then power tools, control speed and torque in drills, grinders and other tools. Again, smart meters, enables real-time data acquisition and transmission in electricity and water meters. So that's all. If you have any doubt, just mention it through comment, okay? Thank you. Have a nice day.